Still continuing with our lesson, continuing with our gas laws. The gas laws. Alright. So now the physical conditions of any gas can be defined by 4 variables. So we have 4 variables that we will use to define the physical condition of any gas. So as we are talking about gases. So the first one is pressure. Pressure. And pressure is measured in pascals. Yes, in pascals, PA. And 2, we have the temperature. Temperature. So in this case, temperature will be measured in kelvins. And the third one will be your volume. So volume, it will be denoted by we can use measure volume in ATM, atmospheric pressure, or liter. No, this one is the pressure. You can measure it in liters, milliliters, any SI units that are used to measure the volume. We'll use them. And the last one, it will be your number of moles. The number of moles. Number of moles. Okay, you can put this one will be denoted as P. This one will be denoted as T, temperature. This one will be denoted as the volume. This one will be denoted as the small letter N, stating for the number of moles. Now, the specific relationship between the variables are called the gas laws. That is why this topic is called the gas laws. We are looking at the specific relationship. For example, let's start with the volume. Volume and pressure relationship. So now this relationship was discovered by Boyle, and now it is known as Boyle's law. He is the one who came up with this, who discovered this relationship. So Boyle's law states that the volume of a fixed amount of a gas is inversely proportional to the pressure of the gas if the temperature remains constant. So Boyle's law found that where the volume is inversely proportional to the pressure, and provided that the temperature is kept constant. So mathematically you can say V, and then we write a proportional sign and have P, and then we are saying this volume is inversely proportional to the pressure, provided that temperature remains, temperature is constant. Yeah. So we have our formula as P1 V1 is equals to P2 V2. Then here is the formula that represents the relationship. Then, since we have this relationship, we can graphically use graph to represent this relationship with the use of graphs. Now, when plotting a graph, you find that you will have your pressure and your volume, and the x, and these are your y-axis. And then we'll have this type of relationship. That is, pressure is inversely proportional to the volume. Or, if you like, you can write it as like this. We'll have your pressure and then straight line from 0. This is 0. From 0, and then you have a straight line, and then here you have 1 over V. That means you will write the reciprocal of the volume here. It's the reciprocal of the volume that is directly proportional to the pressure. It is the reciprocal of the volume that is directly proportional to the pressure. While here we're saying the volume, it is inversely proportional to the pressure. This has the same meaning, but it is plotted in different ways. Moving on now, you can open your tablets. I've uploaded some few problems on this concept on your learning site. So the problem, I'll first wait you open your tablets. All right. So the problem states that we'll use this problem as our example. So the problem says that a gas occupies a volume of 1 liter. So we have a volume of 1 liter. That is the first thing we're given, a volume. And exert a pressure of 400 kilopascal. So we have P, the first pressure is 400 kilopascal. And then exert 400 kilopascal on the container on the walls, or on the walls of its container. What will be the pressure exerted by the gas if it is completely transferred into a new container? So now, what we have asked is second is P2 as our pressure, and it is the gas was on 1 liter container, and now it is moved to 3 liters container. So our second volume is 3 liters. Then we are asked what is the pressure. So what we are going to do, we will use this formula here. So we have P1 V1 is equals to P2 V2. Then substituting from here, our first volume, our first pressure is 400. And then we have our 1 as our volume. And then we're looking for P2. And then our second volume is 3 liters. So you will divide by 3 on both sides, and then P2 should punch in your calculators. What is the answer that you are obtaining? So yes, our answer is 133, 3 kilopascal. And that is how you use this equation from Boyle's law to solve problems. So yes, based on what I've just presented, anyone with a question? No one with a question. Thank you.